guys, today is just a day where you get to go ahead and watch some notes and just take in some new information. Tomorrow there is an optional Zoom call as well as a worksheet workday on the concepts that we will look at today. So once you're done with the video, you get the rest of the day math free. Okay, today we're going to focus on something that are called direction angles. And so they're going to start off saying if vector u is a unit vector. And remember what that means is that its magnitude or length equals 1, such that theta is the angle measured counterclockwise from the positive x-axis. So guys, what they're doing is they're going to tie everything all back together. So they're using the x-axis, the positive x-axis, and it is going counterclockwise, and it has a length of 1. What does that sound like to you? How about a unit circle? Because that's what they're doing right now. They're taking a unit vector, so it would have a radius of 1, and they're graphing it counterclockwise from the positive x-axis. Okay, so this would be the vector that they're talking about. Now, rather than calling it a terminal side of the angle, it's a vector because it doesn't go forever. It has its initial point, it has its terminal point. So you guys, kind of cool. So now that it's on the unit circle, it's more familiar to you. You have vector u, its component form. Remember, you have your x value and your y value. Well, if it's a unit vector and you're going off the positive x-axis, making it a point on the unit circle, your x is the cosine value and your y is the sine value. If you're writing it using your i's and j's, remember I means the x term, j means the y term, you can write it like this. And so here is a visual just helping you realize that you guys, we are back to the unit circle. This angle right here, that is called the direction angle. And we have used this angle, you guys, many, many times. We called it a reference angle at some points. When you're just graphing and looking in terms of vectors, it's a direction angle. So kind of cool. It says, suppose that vector u is a unit vector, and it does have a direction angle. Okay, if v equals a times I plus b times j. So again, you have an x value and you have a y value. Your component form is AB. It's just an alternate way of writing it, doesn't change the meaning, okay? Is any vector that makes an angle theta with the positive x-axis, then it has the same direction as vector u. So here's kind of what they're talking about, and we're going to jump down in a second here, and I put a couple questions just to kind of help this to make more sense. So here's the formulas that they give you in the book. And yes, sometimes when you look at formulas like this, it can be super intimidating, okay? That just looks wild. What they want you to remember is that this symbol right here, this notation means the magnitude. So the magnitude of your direction angle, then this is the x value, this is the y value. The other way that you can write that is the magnitude would have to be distributed. It's a scalar multiplication problem. It would have to be distributed to both the x and the y, and the I goes with the x value and the j goes with the y value. So looking at this, using the equations from above, if this is the problem, what would be the magnitude, what would be the direction angle? Well, you guys, the magnitude is this notation. Your direction angle is theta. So all you're doing here, you're not calculating anything. You are taking information out. The magnitude. If I look at this notation, the magnitude is the value in the front. So the magnitude is 5. That's the length of that direction angle or that vector. Your direction angle is theta. Well, this is the cosine of theta and the sine of theta. So in the place of theta is 30 degrees, and that's it. The first part of the section is just having you get used to the notation and what do those things mean. So one more just to make sure. So magnitude, if this is my equation, vector v equals 8 times the cosine of 135 times I just means this is the x value, plus the sine of 135j, this just means it's the y value. The magnitude is the value out front, so the magnitude is 8. Your direction angle is theta. Well, what is theta? It's the sine and the cosine of theta. In this case, it's 135. You're done. Okay, so that's what that first part means. Here's some other information that they gave you in the book where I put let's draw it out. What I did is I included a visual. Had we been in class, we would have taken the time to kind of draw this out for you to see that, yes, this is a point on the unit circle. But in order to keep the video not so stinking long, I did put the image there. But other things that you want to remember, the tangent of theta. So if I am looking at this, let's say that I want to find the direction angle, okay? Tangent is sine over cosine. Okay, so you can go ahead and just remember tangent is sine over cosine. That's one thing that they want to make sure that you remember. Now looking at it using this format, well, you could say the tangent of theta equals whatever the magnitude is times the sine of theta over whatever the magnitude is times the cosine of theta, because it's not always going to necessarily be a 1. It's always a 1 if it's on a unit circle, but we're looking at vectors. Vectors can have any length of a magnitude. The exception is the unit vector, then it would have to have a magnitude of 1. Okay, if you're looking at things in this form, they said, hey, what if you have this? What if vector is AI plus BJ? Okay, that is the same thing as saying whatever we have for a magnitude times the cosine of theta I plus whatever we have as a magnitude times the sine of theta j. These two things mean the same thing. This is the shorthand way of writing that. So if the tangent is sine over cosine, looking at it this way, you could also say, hey, tangent is b over a, because technically this is the sine and this is the cosine. So these are different things that the book would have explained if you go ahead and read this section that I think are important that you just have on your notes. And we will look at how all this works as we go through the examples. So right now we're going to focus on, well, what the heck does this mean? Okay, so it says, let's look at this in a different format. So again, rather than writing the sine and the cosine, they are giving us values, okay? So we have, this is technically the cosine. It's a positive value, so the cosine is positive. This is the sine value because it's the y value. The sine is positive. The sine and cosine are positive in quadrant 1. So we have quadrant 1. Okay, that's important to know. Now, if they want us to find theta, theta is the tangent of b over a, so 3 over 3. So the tangent of theta equals 1. If I want to solve for theta, I can do the inverse tangent of each side. So the inverse tangent of 1 equals theta. Make sure your calculators are in degree mode when we're doing this. So degree, yep, I was in radians. We're going to degrees. Inverse tangent 1, 45. Now you have to make sure that whatever measurement our calculator finds, it is in the quadrant we're looking at. 45 degrees is between 0 and 90, so yes, it's in quadrant 1, so that would be your answer. If you're like, holy crap, okay, because I remember learning this stuff. This is the kind of stuff where in my mind I would be saying, holy crap. So we are going to do a few, guys, don't worry about it, okay? So if my vector is negative 4i, this is the x value is the cosine, so in this case, the cosine is negative. Minus 7j, this is the sine is also negative. So you have to think in your unit circle, where is both the cosine and the sine negative? That means you're going to the left and downwards, so we have to know that we are looking at quadrant 3. That is very important, okay? Now, if I want to find theta, which is like this, okay? It goes all the way around here because it has to end in quadrant 3 because our sine and our cosine are both negative. We have the tangent of theta equals b, negative 7, over a, negative 4. And I got that formula from right here. They said if it's written in this format, this is the formula that you use, okay? So I have negative 7 over negative 4. Well, I can cross off the negatives. If I take 7 divided by 4, it's 1.75. I'm going to go ahead and do the inverse tangent. So the inverse tangent of 1.75, that equals theta, which is my direction angle. Okay, so inverse tangent of 1.75, theta is 60.26. Now here's the problem, guys. Okay, 60.26. That is your, remember, reference angle? Because we're in quadrant 3. So that means the angle that is created from the terminal side to the x-axis, this right here is 60.26. But our direction angle has to start here. So I have half of a circle, 180 to get here, plus 60.26, because what you're doing is finding the direction angle, which means the entire thing. Okay, so again, we know it has to be in quadrant 3. If you're looking at a direction angle, it says you have to start with the positive x-axis. So I'm not looking at just this piece. I have to start here. Making it to here is 180 because it's half a circle. This measurement is like your reference angle from the x-axis to your vector, or what we used to call the terminal side. This measurement right here is 60.26. So you have to add them together. 60.26 plus 180, your direction angle is 240.26 degrees. The big thing is making sure you are comfortable with what quadrant are you in. Again, I'm not making you just do 2. That's why today is just notes. Let's do another one. This is in the format AI plus BJ. If you're looking at it that way, your tangent of your direction angle is B divided by A. So again, before we start, you have to know what quadrant you're looking at. So you're looking at your X and Y value to see, are they positive or negative? The cosine is the X value. The cosine is positive. The sine is the Y value. The sine is negative. So what this means is I'm looking at the quadrant that goes to the right and down. So that is in quadrant 4. So I need to find this angle right here. It's going all the way around the circle because you have to start at the x-axis, going the positive direction, and you're going to be ending in quadrant 4. Okay? What we can find is this measurement right here. The way I can find it is the tangent of theta equals B, negative 4, over A, 3. So I can take the inverse tangent of negative 4 divided by 3, and that's what theta is. And just in case you're like, how do I do that again? Inverse tangent, so I go second tangent. I have negative 4 divided by 3, close it. So it's negative 53.13. Now, the reason why this is negative is because if I visualize this, if I'm starting here, I'm traveling this way. I'm traveling in the negative direction, 53.13. What we need to find is our direction angle starting here, going counterclockwise. What is this measurement right here? So 360 minus this little piece, because that's all we have left to travel to get all the way around full circle, which is 360. 360 minus 53.13, our angle is 306.87 degrees. Okay, so there were 3 examples. So the first thing we looked at today is just notation. If they write it with sines and cosines, you should easily be able to just look at the problem and realize that the magnitude is the number in front. Theta, that's your direction angle. Okay, then the next thing that they said is, hey, what if it is written in this format? How can you do that? One of the main ideas is you need to know what quadrant you're in. You have to be comfortable with, is it in quadrant 1, quadrant 2, quadrant 3, quadrant 4? Then in the book, they kind of gave you a shortcut. They said, well, use this as your formula. Take the sine divided by the cosine because that's what tangent is, sine over cosine, and you can work from there. Your direction angle has to start on the x-axis and travel counterclockwise to where your terminal side, or in this case, your vector, ends. So we were looking at this angle. Okay, now here's the next part. Given a magnitude and a direction angle, can you find the component form? And it says, go ahead and sketch the vector to help. Well, my magnitude is 1. That means, folks, we are in the unit circle. Yep. we're looking at 45 degrees. So if I have this 45 degrees, that is in between 0 and 90. So this is the vector we're looking at. Okay, we're looking at this right here. It starts here and ends here. Well, if this is 45 degrees, you guys, unit circle, this is square root of 2 over 2 and square root of 2 over 2. If I'm starting at 0 and it's a unit circle, that's my component form. What is the x value? Square root of 2 over 2. What is the y value? Square root of 2 over 2. Component form, you're done. If it's on the unit circle, your component form is going to be whatever your ordered pair would be on that unit circle. Okay, now this time, not so much. This is not within the unit circle, okay? So this one, to me, this is when it gets fun, okay? So you're still going to draw this out, 150 degrees. This is 90, this is 180, so you're going to be right here. On your unit circle, this would be a negative square root of 3 over 2 times 1/2, okay? But that's if the magnitude was 1. Our magnitude isn't 1. So what they told us on the front side of the notes is what you have to do is take your point from the unit circle and do scalar multiplication with whatever the vector is. So I have this, 3 square roots of 2 outside of negative square root of 3 over 2 and 1/2. So this is your scalar multiplication that we looked at. Top times top, bottom times bottom. Positive times a negative is a negative. The 3 is on the outside. When you multiply radicals, inside goes with inside. 2 times 3 is 6. Bottom times bottom, 1 times 2 is 2. Top times top. 3 square roots of 2 times 1 is 3 square roots of 2. Bottom times bottom, 1 times 2 is 2. That's your component form. So again, 150, it's right here. Your ordered pair from the unit circle is negative square root of 3 over 2 and 1/2. What you have to do is distribute or do scalar multiplication with whatever the vector is. That's your component form. Okay, we're going to step it up one more time. Okay, it's going to be the same idea, but we're just going one more idea. Find the component form for the sum of u and w. So what that means is we're going to do what we just did, but for 2 different vectors. So we'll go ahead and find the component form for vector v, if the magnitude is 5 and we're looking at 60 degrees. Find the component form for vector u, if the magnitude is 5 and we're looking at a 90-degree direction angle. Then we're going to take the 2 component forms and add them together. Okay, so this is where it's going to get a little bit lengthy, but not bad. Okay, so using your unit circle, I would have 5 outside of. If you look at 60 degrees on your unit circle, the ordered pair at 60 degrees is 1/2 and square root of 3 over 2. So your component form, you just have to do scalar multiplication, bring in the 5. So it's 5 over 2 and 5 square roots of 3 over 2. So that is component form for vector v. Now vector u. Magnitude is 5. We're looking at 90 degrees. Your ordered pair on a unit circle at 90 is 0 and 1. So to get the component form, you just distribute in the 5. 5 times 0 is 0. 5 times 1 is 5. Now what they want us to do is find the sum. So if I have 5/2 and 5 square root of 3 over 2, there's my component form for vector v, plus 0 and 5, because that's the component form for vector u. I do need to make a common denominator, so this would be 0 and 10 over 2, because I do need that common denominator of 2. Okay, so I'm not looking at this format, I'm looking at this. To find your component form for the sum, you add 5/2 plus 0, 5/2. 5 times the square root of 3 over 2 plus 10 over 2. Well, the common denominator is 2. 10 and 5 square roots of 3 are not common terms. They're not like terms. You can't combine them. So it is 10 plus 5 square roots of 3. It is okay to have an answer that looks like this. This would be the sum. one more, and that is it for the day. You'll see down here it says worksheet, but tomorrow is a workday worksheet for that. Or sorry, tomorrow is a work day for the worksheet. So you do not have to do it today. Today is just learn some new things about vectors. Okay, so if I'm doing this, vector V, my magnitude is 50, and I'm using the ordered pair from the unit circle at 150. So if you look at your unit circle at 150, you have negative square root of 3 over 2 and 1/2. So to get the component form, you're going to multiply that 50 in. Well, here I can cross cancel. 50 divided by 2 is 25. So this is negative 25 square roots of 3. 50 times 1/2 is 25. So there's the component form for V. Now for U, the magnitude is 20. We are using 45 degrees. Your ordered pair at 45 degrees is square roots of 2 over 2 and square root of 2 over 2. So now I bring in that 20. Again, 20 divided by 2 makes this 10 square roots of 2. 20 divided by 2 makes this 10 square roots of 2. So component form for vector V, component form for vector U. They want us to find the sum. So negative 25 square root of 3 and 25 plus the component 10 square roots of 2 and 10 square roots of 2. Now what you have to realize is that in order to add radicals, they have to have the same radicand, meaning the number underneath. So when I go to add these two things, they are not like terms. So it stays negative 25 square root of 3 plus 10 square roots of 2. That is the x value for your component form. I can't combine them because they do not have a like radicand. Same thing here. 25 cannot be combined with 10 square roots of 2, making one term. They have to say like this. It is totally fine to have a sum or a component form look like this. You cannot combine like terms, so this would be the sum of vector V and vector U. And we have just finished section 6.3. Enjoy the rest of your day. I'll talk to you soon. Bye.